This video is about the chain rule in partial derivative. I will be using this function to explain this chain rule. Z is equals to xy to the third minus x squared times y. Function z has two independent variables, x and y. The value of z depends on x and y, so x and y are independent. Z is a dependent variable. And then each independent variable, the x is in terms of t. Y is also in terms of t. So the function is z is equals to some xy. So z is equals to, on the other side of the equal, I see some x and y and then some constant, whatever that is. I will have two independent variables. The derivative of z with respect to t. So the derivative of z not with respect to x or y is with respect to t. So we will be taking the derivative with respect to t, but we have x and y only. Don't forget that x is in terms of t, y is also in terms of t. So basically the dz dt has two parts. We add them together. One part for x, one part for y. For x, we are taking the partial derivative of z with respect to x. Okay, so with respect to x, then y is a constant. And then we multiply the derivative of x with respect to t. So that is the t in x. So one big part for x, we take care of the z with respect to x first, and then we multiply, we take care of the x with respect to t. And then we plus one part for y, the derivative of z with respect to y, and then we take care of the derivative of y with respect to x. It's like started from left and right, from left and right. We start with z with respect to y, and then immediately starting at y, and then with respect to t. All right, so let's do it. So the dz dt, so the partial derivative of z with respect to t. After this, I will do another example. So what is the first piece? The first piece is the partial derivative with respect to x, then y is a constant. Then I will just take the first term as x times a constant. X times a constant. So just treat the y to the third as a 5 or something. Like 5x, the derivative of that, you only have the constant y. So that is equals to y to the third. How about the next term? X squared times y. Y is a constant, so we will just do a product rule, bring the 2 down, so that will be minus 2x. The constant y stays there. It is weird to say that, but that is what you have to get used to when you do partial derivative. And then we multiply the derivative of x with respect to t, so that will be, you can do a 2t. I prefer to do like a 2t, and then the derivative of 1 is equals to 0. I prefer to use a dot in here as well. So I'm going to move this a little bit, and then I'm going to draw a dot right here. So for multiplication, so I can see that 1 for z, 1 for x, 1 for z, 1 for x, and then I will use the dot to separate them. And then we draw a big plus, partial derivative with respect to y. So this time x is a constant. So for the first piece, we will bring the 3 down. So that will be a 3y squared. X is a constant. We are not touching that. And then only y is a variable. So we have the constant x squared left, minus x squared. And then we draw a dot for multiply, dy dt. So the derivative of y t squared minus 1. So that will be a 2t minus 0. That will be a 2t minus 0. And then once again, this is the partial derivative of z with respect to x, and then immediately we take care of the x with respect to t. This is the partial derivative with respect to y, and then immediately we take care of the y with respect to t. Take care of the y means we take the derivative of y. Maybe when you do works online, they won't just let you leave the answers like that. You might want to fully expand them, cancel some like terms, do some simplification, and then try to see if you can factor something out. That should be pretty easy. Oh, did I make a mistake right there? Okay. When I do the derivative with respect to 1, I think most of you already figured this out. The derivative of 1 is not supposed to be a 1, huh? This is supposed to be a 0. I think most people already figured this out. Okay, let's continue. So we have y squared times 2t. So that will be a 2t times y to the third. Did I say y squared? Y to the third. And then minus 2 times 2, minus 4. And then xyt. Good. And then big plus. 3 times 2 is a 6, and then xy squared and then t minus 2tx squared, like, or 2x squared t, whatever that is. Can we simplify anything? I don't think we can add or subtract any terms, but I see every term shares a t and the coefficient is a multiple of 2. So I will just factor out a 2t, and then I have a y to the third minus 2xy plus 3xy squared, and then minus 2x squared, and then that's it. So this is my derivative of z with respect to t using chain rule. So the derivative of z with respect to t. Okay, so let's practice one more. This time let's just do some tangent and arctangent, shall we? So this time, how about this? I'm going to try like z equals to, okay, let's do a square root of 1 plus xy. And then I am going to let x equals to tangent of t, and then y is equals to, let's do an arctangent. Still remember the arctangent, the derivative? I am looking for the dt, the derivative of z with respect to t. Okay, so that is the dz dt. So first of all, what do? One part for x, one part for y, and then for x, we take the partial derivative with respect to x. So that means we will have to carry the 1/2, right? Because the square root is a 1/2 power. 1 plus xy, and then 1/2 minus 1, negative 1/2, and then derivative of 1 plus xy by chain rule. We are just doing a regular chain rule. So the derivative of 1 is equals to 0. The derivative of xy, y is a constant, x is a variable. So the variable x becomes a 1, then that will be a 1 times y. And then we multiply, so we just complete this, the dz dx, delta z with respect to x. When I was a student, I would just call that a partial z with respect to x. And then we take the derivative of x with respect to t. The derivative of tangent is, still remember that? That is a secant square of t. And then we do a big plus. Now, partial derivative with respect to y, the first piece is the same thing. You bring the 1/2 down, and then 1/2 minus 1 is negative 1/2. The derivative of the radicand, 1 plus xy with respect to y, the derivative of 1 is 0. The derivative of xy, y is a variable, x is a constant, then you have x left. And then we do immediately, we will just multiply the derivative of y with respect to t. So the derivative of arctangent is 1 over 1 plus t squared. Okay, so let's summarize this a little bit. So this is 1 part for x, right? So this is a 1 part for x, and then this is 1 part for y. And then within this, so we have a t in x. And then within the, for y, we have a t in a y. Okay. So that's why I use a dot. Do you see this? Do you see this dot and this dots? So once I use a dot, I can easily check my work. That is the partial derivative with respect to x. And then we take care of the x with respect to t. So partial with respect to y, and then dot y with respect to t. And then let's clean this up. So what do we have? I have the 1 over 2 and then the square root in common. Okay, I'm going to draw that, and then I'm going to factor this, and then the first term I have a y times secant square t, a big plus, and then next I have a x over 1 plus t squared. So that's it. This is my dz dt, the partial derivative of z with respect to t. So that is one of the cases. And then in the next case, I will introduce another function where w is in terms of 3 independent variables, x, y, and z. All right, so I will see you in the next video.